Today, we will introduce creative ideas and devices that help generate electricity from non traditional, environmentally friendly energy sources. From utilizing body heat, vehicle movement, small water flows, to sports activities such as playing football or going to the gym, all show the great potential of exploiting renewable energy in daily life. In addition, the video also mentions breakthrough inventions, such as artificial trees, that simulate nature to generate electricity from wind or devices that absorb environmental temperature differences, opening up new directions for green, sustainable energy solutions that are suitable for many areas of the world, especially communities lacking electricity. Let's get started. Number 1 is harnessing human body heat is a smart solution to generate energy from excess heat in crowded urban environments. At Stockholm Central Station, Sweden, the ventilation system is integrated with a heat exchanger, collecting heat from passengers to heat water, then using it to heat nearby buildings. Thanks to that, an office building has reduced at least 25% of electricity consumption for the heating system. This model not only saves energy, but also reduces greenhouse gas emissions, contributing to environmental protection. This idea is attracting attention from many other public works, such as airports, shopping centers, or large train stations. This is a typical example of taking advantage of passive energy sources, which are often wasted, for effective reuse. In the future, this technology can be widely integrated into homes, vehicles, and even smart clothing. This opens up a new direction for green, sustainable energy solutions that are close to human life. Number 2 is the electric speed bump, a unique innovation that harnesses the kinetic energy of vehicles to generate electricity. Instead of simply slowing down vehicles like a conventional speed bump, the bump, called the electrokinetic road ramp, is designed with compression plates that move as the vehicle passes over them. Pressure from the wheels causes the plates to move, transmitting force to a generator and creating an instant source of electricity. Depending on the weight of the vehicle, each impact can generate between 5 and 50 kilowatts of electricity. This is enough to power devices such as streetlights, traffic signs, or small charging stations without needing to be connected to the national grid. The device is also designed to operate smoothly, without making noise, and without affecting the driving experience. If widely deployed at busy intersections, parking lots, or toll stations, this technology could save a lot of energy and reduce the load on the central power system. Number 3 is the whirlpool turbine, which is a solution to generate electricity from naturally flowing water, such as streams or small rivers, without the need for large infrastructure such as hydroelectric dams. The device consists of a small concrete tank placed next to a stream, inside which is a turbine and generator. When water is introduced into the tank, the flow creates a vortex and spins the turbine, thereby generating electricity. Each turbine can produce up to 100 kilowatts of electricity and has a lifespan of up to 100 years, while not having a negative impact on the ecosystem. Fish and aquatic life can swim through the device without being harmed. This is an ideal option for rural or remote areas where the power grid is not yet developed. The technology has already been deployed in Belgium and Chile and has the potential to be replicated globally due to its low operating costs and high sustainability. This is proof that green energy exploitation does not necessarily come with large scale or negative impact on the environment. Number 4 is push to charge, a technology that uses the piezoelectric principle to generate electrical energy from mechanical force, such as when a user presses a key on a keyboard. This principle is based on the ability of certain materials such as metals, crystals, and ceramics to generate a voltage when compressed or bent. In the case of push-to-charge keyboards, the keys are designed so that when pressed, they act on the piezoelectric materials, generating electricity that is stored in a small battery. This means that users can generate electrical energy while using their devices, without having to charge them through a power outlet. By pressing the keys thousands of times a day, the amount of electrical energy generated can be enough to charge a phone or small mobile device without using an external power source. A phone, for example, could save up to 52 kilowatt hours per year if this technology were widely adopted. If deployed on a large scale, this technology could save significant amounts of energy and reduce reliance on grid power, while minimizing the impact of using energy from non-renewable sources. Number 5 is the electric gym equipment generator, an interesting innovation that turns the body's energy during exercise into electricity. Exercise machines such as exercise bikes, treadmills, and CrossFit equipment can now be equipped with generators that convert the movement of the user into electrical energy. As the user pedals or runs on the machine, the kinetic energy from the body's movement is converted into electricity through a generator mounted on the device. The electricity generated can be used to power lights, entertainment equipment in the gym, or even return some of the energy to the grid. Although the amount of electricity generated by a single exercise bike may only be about 150 watts per hour, enough to power a TV for an hour, if this technology is widely adopted, it could help save energy for the entire gym and reduce electricity costs. Furthermore, gyms equipped with power-generating exercise equipment can also attract customers by promoting their environmental friendliness and minimizing negative impacts on the ecosystem. As the demand for renewable energy increases, these gym equipment can become an important part of the green energy development strategy at sports facilities around the world. Number 6 is the electric soccer ball, a unique invention that combines sport with renewable energy production. Called the socket, the ball has a small generator built into it that generates electricity as players kick the ball. Each ball weighs only slightly more than a regular soccer ball, but can produce enough energy to power a lamp for 3 hours after just 1 hour of play. This technology opens up opportunities to provide energy to communities without electricity, especially in poor areas where electricity is unstable. The idea has been implemented in a number of projects to provide electricity to schools, clinics, and community centers in rural areas. In addition to generating electricity, the ball encourages physical activity and play for children, while also raising their awareness of renewable energy. Although this product is no longer in production, the technology remains a testament to the creativity in combining sports and technology to solve energy and community development problems. Number 7 is the urine generator, a unique and innovative invention that uses a readily available resource that most of us don't think about: urine. In 2012, a group of students in Nigeria designed a device that can generate electricity from urine. This process takes place through the use of electrolysis technology in an electrolysis cell. Urine is fed into the cell, where it undergoes a separation process to separate out hydrogen, which is then used to generate electricity. 1 liter of urine can provide enough electricity for 6 hours, opening up the possibility of generating electricity for communities without relying on traditional energy sources. Best of all, this technology does not create toxic waste, helping to reduce pollution and reuse a waste resource. Although urine-powered generators are not yet widely available, the idea is a testament to the creativity and potential of renewable energy, which could help solve the problem of electricity shortages in poor remote areas. Number 8 is tidal stream turbine, a technology that harnesses energy from natural tidal currents, using underwater turbines to generate electricity. These turbines work similarly to wind turbines, but instead of wind, they use the force from the flow of water to rotate the blades and produce energy. A notable example is the SRMM turbine in the Orkney Islands, Scotland, which generated 3 gigawatt hours of electricity in its first year, enough to power 830 households. The advantage of this technology is that it does not require large dams like traditional hydropower, helping to minimize the impact on the ecosystem. It can be installed in coastal areas with strong tidal currents to create a sustainable and stable source of renewable energy. Tidal stream turbines not only help reduce dependence on fossil fuels, but also contribute to environmental protection and green energy development. This is a promising future solution to provide clean energy to coastal communities. Number 9 is the biomimetic tree, a technology that harnesses wind energy by simulating the movement of natural leaves. The artificial leaves of the tree are designed to vibrate under the influence of the wind, creating mechanical energy and converting it into electricity. Each tree can generate about 80 watts of electricity from a gentle breeze, providing power for small appliances in the home. This technology not only provides a clean source of renewable energy, but is also highly aesthetic, allowing the tree to be integrated into urban spaces without adversely affecting the landscape. The artificial tree can be used in parks, sustainable buildings, or residential areas, contributing to reducing dependence on the national grid and providing a green energy solution. Although this technology is still in the research and development stage, its potential in providing clean energy to urban areas is huge. Finally, the thermal resonator is an advanced technology that can generate electricity from the temperature difference in the surrounding environment. Thermal resonators work on the principle that the difference in temperature between 2 points will generate an electric current. This technology was developed at MIT and promises to be an efficient energy solution in the future. Although the current power generation from thermal resonators is still low, studies show that it can be 3 times more efficient than traditional methods. These devices can be used to maintain environmental sensors or wireless communication systems with low power consumption. With further development, thermal resonators could become an important part of powering small devices or supporting other renewable energy systems.